Have you ever wondered how AI can write an essay, compose music, or create a stunning image from just a few words of text? That magic is called generative AI, and it's changing our world at an incredible pace. But how does it actually work? In 2025, understanding generative AI is no longer optional, it's essential. If you're a student trying to get ahead or a professional looking to leverage the next wave of technology, you've come to the right place. In this in-depth overview, we are breaking down generative AI from the ground up. We'll explore the core artificial intelligence models, understand exactly how machines learn to generate content, and demystify concepts like large language models and diffusion models. By the end of this video, you'll have a comprehensive understanding of one of the most important technologies of our time. So, if you're ready to learn, stick around. Let's get started. What is generative AI? Definition: a class of AI models designed to create new content based on patterns learned from existing data. Learning process: these systems analyze vast datasets to understand underlying structures and relationships. Output types: capable of generating text, images, music, code, and other media forms. Technologies: based on deep learning architectures like GANs, variational autoencoders, and transformer models. Technical architecture: training data. Large datasets containing the patterns to be learned and reproduced. Model architecture: neural networks like GANs, VAEs, and transformer-based systems. Training process: learning to predict or generate subsequent outputs through optimization. Generation: sampling or decoding new content from learned probability distributions. Applications across industries: creative content, article writing, image and art creation, music composition, video generation, technical applications, code assistance, drug discovery, protein folding prediction, material science research, entertainment, game character creation, level design, dynamic storytelling, interactive experiences. GPT, text generation in action. Data ingestion. Training on diverse internet-scale text corpora spanning numerous domains and languages. Pattern recognition. Learning language structure, semantics, and contextual relationships between words and concepts. Predictive modeling. Developing statistical models to predict likely next tokens given previous context. Content generation. Producing coherent essays, answers, summaries, poems, and even functional code. GANs, revolutionary image creation. Random input. The process begins with random noise as seed data. Generator network. Transforms noise into candidate images attempting to mimic real data. Discriminator network. Evaluates images, distinguishing between real and generated samples. Competitive learning. Both networks improve through adversarial training until generation is indistinguishable from reality. Diffusion models, the new frontier. Forward diffusion. The process begins by gradually adding noise to training images until they become pure noise. This creates a mathematically tractable transformation path for the model to learn. Neural network training. A neural network learns to reverse this noise-adding process through sophisticated optimization. The model estimates the direction toward the original image at each noise level. Reverse diffusion. During generation, the model iteratively removes noise from random starting points. This gradually reveals coherent images guided by text prompts or other conditioning. Ethical considerations. Misinformation risks. Synthetic media can create convincing falsehoods. Deepfakes threaten authenticity of visual evidence. AI-written text can spread misinformation at scale. Bias and fairness. Models inherit biases present in training data. Can perpetuate harmful stereotypes. May provide unequal quality of service. Intellectual property. Copyright questions around training data. Ownership of AI-generated content remains unclear. Threatens livelihoods of creative professionals. Current limitations. Factual accuracy. Models can hallucinate information, presenting falsehoods as facts with high confidence. Reasoning ability. Complex logical reasoning remains challenging despite superficial linguistic competence. Context length. Most models have limited context windows, restricting their ability to consider long documents. Computational cost. Training and running large generative models requires significant computing resources. Temporal knowledge. Models have fixed knowledge cutoffs and cannot access real-time information. Future directions. Multimodal integration. Seamless combination of text, image, audio, and video in single models. Human-AI collaboration. Tools designed for real-time creative partnership between humans and AI systems. Domain specialization. Highly optimized models for specific fields like medicine, law, and scientific research. Safety advances. New techniques to align AI systems with human values and prevent harmful outputs. The best way to stay updated with our latest content is to subscribe and click the bell.